this presentation is from actually a project that wasn't too far long after the one we were on, Ashish. Um, it wasn't one that I was directly involved in, but one I was helping out a fellow coworker. And I'll change the name of him because actually some of you know, know him, but we'll call him Joe. How about that, Joe? I was at my desk. This is back when we were doing all in-person meetings, or not all in person. We were like actually in a physical office. I haven't been in one of those in a while. So I actually had to like get dressed today and all that sort of stuff. And so I was just sitting at my desk, and then Joe comes over to my desk and he's got this like really, really worried look on his face. And normally he's like super stoic. He doesn't show any emotion. Like when he told us that he had newborn children, he's like, where were you last week? He's like, oh yeah, my wife had a child. I'm a father now. I'm like, dude, what, what the hell? Why didn't you tell us this is even happening? So he's just like totally stoked. But he showed up at my desk that day with a very worried look on his face. And I knew that if he had a worried look on his face, that something was probably very wrong. So he says, well, I was reviewing code for our clients and just kind of going through the main parts in the system. And I was looking at like some of the most important code of the system and noticed that there's something that could go really, really wrong. And so he wanted to grab me into a conference room and just say, hey, am I on the right track here? Am I seeing the same things that you're seeing? Is this as bad as we think it is, or is potentially bad as we think it is? So I tried to boil this down to 6 lines of code of the things that he was most concerned about. That was, like you're saying, he was keeping him up at night. And so this system was a reservation system, but the key part of it was there's a part of the system in which the customer is giving you money. So this is the part in which you're at the very last screen of like the checkout process of this web app. And you look at your order, everything looks good. And there's a big green button at the bottom that says place order. And so this set of code is the code that runs after you click the button that says place order. Now I'm going to abbreviate it. There were more lines in 6 code, but whatever. This is like as much as I could distill down into 6 lines of code that were keeping him up at night. So it was an MVC app. So this was the action in the controller that was processing the order or the request to make an order when you click the button to say place order. So it takes in your shopping cart information, so the things that you've set aside to say, I want to purchase. And the first thing it does is it pulls the customer information out from the database. Nothing too terrible so far. The next thing it does is it creates an order based on the cart information and the customer details. So behind the scenes, it's taking the cart, grabbing the items out of the cart, creating an order object, stuffing the order object with the stuff in the cart, and then also transferring over your customer details as well. So far, so good. The next part is when it starts to get interesting, and this is why I could see that my coworker was starting to start to sweat a little bit. So after it inserted the order into the database, the next thing it did was use a payment gateway. In this case, they're using Stripe to post a payment over to Stripe. Now, once the payment to Stripe was posted successfully, we want to send the order details to the customer. You know, you always see this, right? You place an order, and then like 3 seconds later, you see the email in your inbox. Thank you for your order. Here's a link to the details, blah, blah, blah. So we used SendGrid, which has a great API, to send a thank you email to the customer to say, you know, here's the link for your order details. Thank you for your order, all that sort of stuff. Once we've done those 1, 2, 3, 4 things, this system wasn't responsible for all of the processing of an order. It couldn't do absolutely everything. There were other downstream systems that had to be notified when orders came in. And so to make things a little bit easier for ourselves, we implemented a pub sub model on top of RabbitMQ. So when an order was placed successfully, we would publish the message via RabbitMQ to notify this downstream systems that we have a new order coming in and it's time for you to go ahead and start processing the order. Finally, once these kind of immediate actions are successful, then we redirect the user to a success page. So after you place your order, it's, you know, thank you for your order. Here's a link to the thing to go click to see the status, whatever. And then outside all of this, you don't see it in this set of code, but there's like some middleware going on that would actually do a save changes on the DB context. So behind the scenes, that's actually committing the changes to the database in a transaction. So the transaction for the database wasn't way up in the create order part. It was like, well, maybe we'll do like 6 things, and then we want to do all 6 things together. And so when we call save changes, all 6 things go out to the database there. That was done in middleware somewhere outside of the set of code that I hunted around and made sure that was I understood where that was. So Bill, sorry, not Bill, gosh, dang it, Joe. Now I gave it away, dang it. So yes, Joe and I, sitting in the conference room with this code on the screen, said, okay, I can see there's a problem here. And the problem is that none of this code that we're looking at here takes into account any sort of failures with any of these systems that it's talking to. So each of these lines of code didn't have any sort of like failure or anything. I mean, there might be like a try catch somewhere buried underneath, but the application business logic didn't take into account any of those kinds of failures. One of my favorite quotes from the old Mythbusters was that failure is always an option. That is, we should always take into account that failures can happen with distributed systems. I mean, even if we're dealing with one single system, like databases can go down. But as soon as I start to introduce more and more systems, the probability of failure starts to go up because I'm compounding the probabilities together. As soon as I chain something together that says all of these things in the chain have to succeed or if one link fails, the whole chain fails. But none of this code was doing anything with failures. It just assumed kind of with, blind ignorance that everything will always succeed all the time. And to be fair, that's like the easiest mode of programming, right? Just like, assume everything's going to succeed and everything's going to be okay. And for most systems, that could probably be okay. But that set of code was like the most important 6 lines of code in the entire system, because if those 6 lines of code didn't work, then very bad things would happen to the business. So I said, okay, Mr. Coworker, before we go to the customer and give them the bad news that like they're about to go live with a system that has some very bad failure modes, let's just walk through and understand how bad can it get. So we broke down the system into each one of its calls and said, okay, let's just walk through what would happen when one of these things fails. So it looks something like this. We make that first call to the database to get the customer details and insert the order. That basically starts the transaction. Then we make the call to Stripe. We make the call to SendGrid. We make the call to RabbitMQ. And then finally, around all of that, we commit the transaction. So I said, okay, let's just walk through these one by one and ask ourselves, not if one of these calls fails, but when one of these calls fails. What is the experience to the customer? What is the overall consistency of the system? And what is the impact to the business? Now, I was very careful on using the word when and not if something fails, because if you use the word if, most business folks and developers get this like kind of happy ears and think like, well, what's the remote probability that will actually happen is like 0.01%. Well, 0.01% is still 1 out of every 10,000 customers. And those, if it's 1 out of every 10,000, that can really add up to, bad press, bad reviews, all those sorts of things. We probably don't want even, 0.1% to have disastrous consequences. So one by one, let's see, based on each one of these calls, what happens when one of these calls fails? So what about the first one? I do the initial, like I'm on the place order screen, I click the button, and just when it tries to get the customer details and insert the order details in the database, something goes wrong and I can't make that connection, can't do that initial insert. Now, you may ask yourself, like, what's the probability that that would happen? Like, if I was on the place order screen, which is like, that's probably reading from the database, and I go to the place order or the processing the order, what's the probability that the database goes down within that, that little bit of time there? Well, if you've ever used Azure SQL, you know that can happen like all the time. And in fact, there are built-in capabilities to ORMs these days to deal with just that like Azure SQL issue of things going wonky with networks and they're like rebalancing something behind the scenes. It's, platform as a service, so you don't have any visibility into like when they decide to change networks on you. It just happens and you just gotta have to deal with it. So it definitely can happen. I've seen it happen plenty of times. So we can't just like, well, because it's remote, then, let's just not even walk through what would happen. It's still important for us to walk through each one of these different failure modes, understand what the potential impact is before we look at, risk and probabilities. So this one, what happens when they first call to the database fails? Well, I haven't done anything yet, really, right? I've tried to insert something into a database, but I'm not committed to a transaction. So if something goes wrong there for whatever reason, the transaction never gets committed. So the transaction would then roll back. I would probably have an error shown to the user. Hopefully it's not a bad error, like, here's a yellow screen or white screen of death with, cryptic error messages. Hopefully it's something nice to show to the user. But they still, they're still probably not too happy about things. But at least the system is consistent. And when I mean system, I don't mean just like the database system. I mean all the systems pictured and any other one that's potentially impacted here that could be connected to any one of these boxes on the screen. So it's not a good place to be in. Like the customer's probably unhappy here. The error page may say, please try your order again. And I may be like, probably not. If I'm shown an error on the screen in which I'm giving you my credit card details, I'm probably not going to try again. At least not right away. I might wait like a couple days, check my credit card statement to make sure I hadn't been charged. And then maybe I come back again. So, potentially some lost business there, but the customer's annoyed, but not like they're not out anything other than just being annoyed. From a business perspective, this isn't good because they can't take orders. So they're going to be annoyed that this is happening. But ultimately, like they're not getting sued or anything, hopefully. All right. Next, what happens when Stripe goes down? Again, Stripe, third-party API, so we don't own that API, and they probably don't ever want to go down. So Stripe service itself may have very, 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 very good uptime. But the reason why that our API cannot successfully communicate to Stripe isn't necessarily that just like Stripe is down. It could be that in that little arrow between API and Stripe, there could be a number of network issues that happen from, the networking changed on our side. We could have had someone turn on firewall rules for whatever reason. I've had that happen. It could just be that maybe there's some DNS issues. Who knows? There's just something that went wrong, me talking to Stripe. Now, assuming that the failure was I wasn't even able to talk to Stripe in the first place, then in that case, we're still in an okay spot. So we get an exception. So the exception bubbles up from talking to Stripe. No money posts to Stripe. The database transaction rolls back. And at this point, the system is still consistent. It's not a great experience for the end user because they're seeing that error screen again. But like we didn't take their money and there's not like any kind of phantom orders around or anything like that. So from a system perspective, at least we've maintained consistency. This is the last point in this exercise where things are like kind of okay. As we go on, things are going to get progressively worse. So next one, what happens when SendGrid goes down? And again, like they very, very rarely go down. They're one of the most consistent APIs that I've ever dealt with. But it can happen for whatever reason that I can't communicate from my API to SendGrid. For example, what happens what happens when we are using API keys to SendGrid? Those API keys expire, but we forgot to rotate them in our configuration of the API. So we get like an immediate unauthorized and probably some message saying, hey, dummy, go update your keys. But the problem is that one, we first tried to insert the record into the database. So that first part succeeded. So we're kind of holding on to that transaction uncommitted. But we make the call to Stripe. Now the call to Stripe succeeds, which means we take their money. We then go try to make the call to SendGrid, but that fails. That fails and throws an exception. The exception bubbles up to our application, which catches it, rolls back the transaction, and then brings the user to that error page. We're sorry, something went wrong. Can you please try your order again? Customer being a little skeptical, probably doesn't try the order immediately and waits a couple days to see if the money posted. After they wait a couple days, they look at their credit card statement of the bank account and notice, wait a second, the money did post. The money was taken out of my accounts and I never got an email saying, thank you for your order. So like they took my money and never gave me the thing I was ordering. So I contact customer service and says, hey, you charged me for something, but you never gave me the order. And they're like, oh gosh, I'm so sorry. Can you give me your order number? I'll look it up. There's a problem. What order number? We tried to insert the order into the database, but because of the exception, we never successfully finished that operation. The order never made it into the database. So the customer says, I don't have an order number. All I saw was like this error screen, and that's all that happened. So the point customer service is annoyed because, like, okay, do they know if this person is telling the truth or not? Like, how do they remediate this? So now we have to get with the admins. Admins had to look at the Stripe logs and say, oh, yes, we did charge a customer this. And we can't track it to an order in our database. So it's just some phantom order that we charge customers money. So not a good thing. So in this case, the customer is charged, but the transaction rollback, so the system as a whole is inconsistent. So like the overall business system, the business transaction is not consistent, and people are upset. So customer's unhappy, customer service is unhappy, system is inconsistent. Business may be okay with this, right? Because hey, they're raking in money still, like, the lines are going up. But from a eventual business perspective, like, they're not going to be happy because people are complaining, like the order system's not working and it's taking my money. Not a good thing, not a good place to be in. All right, let's keep going. What happens when RabbitMQ goes down? Ooh, this is getting worse and worse. So we opened the transaction, inserted a row into the database, but again, it didn't complete the transaction yet. We made a call to Stripe, we took their money. We called SendGrid, that call succeeded, so we sent them a thank you email, but the call to RabbitMQ failed, threw an exception, and then rolled back our database transaction. So the customer was charged and notified, but the transaction rolled back. So again, the customer's upset. Hey, I saw an error message. I didn't see my order details, but I got an email that said, hey, thank you for your order. However, when I click the link to say view order details, it just shows the screen, order not found, because the transaction rolled back. So we're in a even worse place than we were before. We did take the customer's money, yay, but we can't fulfill the order because we lost the order details. The cart's gone, the order is not there, and again, people are upset. Finally, the worst option, which is what happens when the database transaction fails. So in this case, we've made the call to Stripe, taken the money. We've made the call to SendGrid, notified them that the order was successful. We made the call to RabbitMQ, notified downstream systems that it's time to process their order. However, because something went wrong with committing the transaction, the order never successfully gets inserted into the database. So at this point, the system is royally screwed. We don't have any record of the order. We have customers upset. We have downstream systems confused because they're trying to process an order that doesn't exist. And at this point, the business is probably like, you developers have no idea what you're doing because look at all the things, look at all these complaints we're getting in from customers, and we can't even track down what the heck happened here. So this was the problem that we were presented with not too long to go live. So we were like, what do we do now? So how do we fix this? And right now, the system is just shrugging its shoulders. But just shrugging your shoulders is probably not good for business, just to say, things will probably succeed, probably be good. So let's just not worry about those failures because they're annoying to deal with. And they are. But just shrugging your shoulders is probably not good for business. If you have lots of failures and it's even just a few failures, it will trickle out to reviews and all that sort of stuff. So just like pretending like failures don't exist is probably not going to be good for business. So I know how to fix this. The problem is we have this box for the transaction that says it needs to either all succeed or all fail. What if we just go, ugh, and stretch that transaction around everything? So everything succeeds or everything fails. Now, there are ways to do this. Like there are ways to do complex transaction protocols over various transports and enlist all these different other resources in these transactions. But it is quite expensive from a resource perspective and quite expensive from a communication perspective. So this, in practicality, just won't work. Either it's not supported, or as we'll see in a little bit, it is much more difficult to do in practice and introduces a lot more overhead. But in our case, like Stripe and SendGrid and RabbitMQ don't allow this anyway. They don't allow this kind of like, well, just we'll list in other people's transactions because reasons. They don't allow this. So we can't just like anything we want to do, they want it all to succeed or all fail. We can't just like wrap a transaction around the whole thing. It's just not possible in almost all cases. So if we go back to the original set of code, the problem we had was the code assumed that failures would never occur. But if there's anything that I've learned in software development, especially with dealing with distributed systems, is we have to assume failures occur. We have to plan for the worst in our systems. Now, what our options are and how we deal with those failures are oftentimes a business decision. So it's not just up to us as developers to understand what is the right thing to do in the face of failures, but we can't just assume that things are going to succeed. We have to assume that things are going to fail and plan for the absolute worst. Now, luckily for my coworker and I, this was not an unknown problem. This was something that has like been part of distributed systems since like the dawn of communication. And so there's a great paper I looked up at the time that's helped guide us into understanding what are the options for dealing with failures and which are the right options for us to choose based on the different constraints we were dealing with. And this paper is called Your Coffee Shop Doesn't Use Two-Phase Commit. And two-phase commit is that protocol to enlist the world in a transaction. And so Gregor Hope was sitting in, well, it still used to be Starbucks doesn't use two-phase commit, but I think Starbucks, like, I don't know, trademarked them or something, said, please don't use our name in this goofy paper. So we changed it. Your coffee shop doesn't use two-phase commit. But he was sitting in a coffee shop and he noticed that the overall business transaction of ordering and receiving a coffee is not done in a single synchronous transactional operation. Instead, we have multiple actors using a variety of communication mechanisms in order to coordinate the overall business transaction of me receiving that's mocha latte or whatever. So as he was sitting there, he thought through, well, what are the different ways we can deal with all the different kinds of failures and the different options for the different ways different occurrences of having two different resources or actors wanting to perform an operation together. So the first one he looked at was ignore. So I perform an action with resource A and resource B. Resource A succeeds and resource B fails. And the ignore option is just to simply, well, ignore it. If something happens with resource B, we just do nothing. We just move on and pretend like it didn't happen. And then maybe say to yourself, like, when would I ever do this in a real system? Like, why would I ever ignore a failure? But there are probably cases in your system today that you don't even realize that you are ignoring those failures, hopefully with a good reason. But there are certain cases where you're doing two actions with two resources, but you don't care if the second resource fails. And a good example is something like logging. Do I want my system to go down if I cannot reach my logging provider? Probably not. I probably don't want logging to be the thing that takes my system down. So around all those things that are like pumping out logging messages to, wherever, hopefully not disk, somewhere, pumping out those log messages somewhere, there's probably a try-catch around that says, try to pump the messages out. And if it fails, like whatever, we'll log that message to you, haha. But we won't we won't take down the rest of the system because of that. But it's still a valid option for us to consider when looking at all these different resources that are going to be in one single operation. Second option is to retry. So we perform the action on resource A. We perform the action on resource B. Resource B fails. And so at this point, we try that operation again. Now there's some subtlety here, right? We have to make sure that the operation we're doing on resource B is, quote, retryable. There's a fancy term for that, idempotency. It could be that we try the operation on resource B. We didn't wait long enough to see if it was successful, and then we tried it again. So it could be just like some other failure in the communication, but resource B was like actually successful, but didn't tell us it was, or we just didn't wait long enough. So we do need to make sure that if we perform that retry, that resource B is able to handle that retry. We also have to deal with like transient versus permanent failures. Well, like if resource B moved somewhere else, we can't just keep trying it again and again. It's like permanently going to fail. And so we can't retry forever. So we're going to have some intelligence if we perform this operation. We can't just like while not success, keep retrying forever and ever until the heat death of the universe. Probably not what we want to do there in the retries. Next option is to undo the operation. So in this case, we perform the operation on resource A. It's succeeded. It's not in a transaction. The transaction succeeded. We go to resource B fails. And now, because of that failure, we go back to resource A and ask resource A to undo the operation. Whatever that means for whatever that operation was, this is more of a design question at this point. Maybe it's a business decision and business question. What does it mean to undo this thing that you just did? So we'd ask, regardless of what the design is, we ask resource A to please undo the thing that you've done. And you've done this all the time, right? Like you're going through the checkout process, you decide, oh, I don't really want this thing. And so the undo is to remove the item from the cart. So we'll have to figure out what that means for our different operations that we're dealing with, but this is something we want to consider. And the final one is this actually two-phase commit protocol. So in this one, we're coordinating a transaction between resource A and resource B. And so the two-phase commit protocol works by the first phase asking each resource to prepare its resource for a transaction. So it asks resource A, can you do this? Ask resource B, can you do this? Resource A and resource B then give feedback to the coordinator that says, yes or no, I can perform this. The coordinator keeps track of the communications and the responses. And once it's received a thumbs up from all the resources, at this point, we're locked in. There's no going back. So resource A and resource B, once they've given a go-ahead, they have to wait for feedback, communication from the coordinator to say, go ahead and commit the transaction, or just kidding, go ahead and release those resources. So the coordinator, once receiving everything, it will communicate to resource A and resource B, a thumbs up or thumbs down based on the feedback it's received. Now, you may notice there's more arrows here. So this protocol does have more overhead in terms of communication. Plus we got the green box, right? There's this green box off to the side that is performing this coordination between these two different resources. So you might think, well, when would I ever choose this? But this is something we actually do see in life, and in maybe not daily business, but we do see this. If you ever had to do any kind of real estate transactions, you probably had to work with a title agent or broker who is this coordinator that's working with the buyer and the seller. They go to the buyer and say, are you good for it? Do you have the deposit? Do you have the money? Okay. And then they actually, they show you the check, like, yeah, here's the cashier's check or whatever. It says, yes, I got the money. Here it is right here. And I'm putting down, I've got in front of the bank. Here it is. Resource B, okay, seller, do you really want to sell this for X amount of money? And then they'll sign a contract saying, yes, I do want to sell this. So like legally binding sort of things. And so once they give that feedback, okay, now the coordinator takes the money from resource A, gives the money to resource B, along with like 1,000 papers to sign. And now we've completed the overall business transaction. So that operation is not free in real life, neither in time, effort, or even money, right? We have to pay that person to just like watch us sign papers. And so it does perform a valuable service because I don't want to deal directly with necessarily the seller and buyer directly, right? I want to have a little bit more guarantees going on here and with some legal protection, but it incurs some overhead as part of this. All right, so my coworker and I, this was our master plan. We were going to examine each of the external resources, look at the 4 possibilities of dealing with options for failure, and then pick the best option based on our individual business requirements. Okay, so first up is Stripe. So just a refresher, this is our code. We've got 2 lines of code that insert this, that select something out of the database, insert something into the database, make the call to Stripe, make the call to SendGrid, call outs to RabbitMQ, and then finally somewhere on the outside is the transaction here. All right, for Stripe. Option 1, ignore. So this would be something like try catch around Stripe, and if it fails, like, oh well, we gave it our best to take their money, but it didn't work, but you can still get your stuff anyway. It's fine. Business may not agree with this. Like from a business perspective, they probably don't want to ignore a failed payment. There are a million reasons why a payment may fail. Like they may have their credit card information wrong. They may not have sufficient funds. They may have an expired credit card, or Stripe could be down. Who knows? but we probably don't want to just allow anyone to place an order and not actually take their money for the thing they're actually ordering. So the business would say, no, actually we want to make money. Money is how we pay the bills here. So let's not ignore that. Now in real life, this actually does happen. Like if you're ever, I don't know, I've been to, gosh, outdoor festivals and things like that, where they have to use those little credit card machines that have to communicate via cell networks. And they have to make a choice when their little machine goes down. Do they want to make everyone upset that they can't take the money because this, little doodad doesn't work anymore? Or do they want to say, well, do you have any cash? No cash. Okay, fine. You can have this paddle corn or whatever. It goes bad at the end of the day anyway. So whatever. But it still could be a business decision as a developer, product owner, whatever. I will be balancing all these different things to understand what makes sense from a business perspective in terms of a failure to pay us money. All right, so option 2 is retry. Ooh, so this one's tricky because if you remember earlier, I talked about that we could make calls out to these services and they might actually succeed, but we didn't wait long enough to get the successful response back. So it could happen that we make a call to Stripe, but there's something going on with network connectivity errors, whatever. We make the call. We never get the response back from Stripe. We get a timeout error. And we're like, well, I don't know if that succeeded or failed. Let's just go ahead and post the transaction again. If we don't do anything, it could happen that we accidentally take the customer's money twice, which may be good from a business perspective because, hey, like numbers keep going up. But from a customer's perspective, they're like, wait a minute, you double charged me. I don't like that. You charged me twice and I only got my product once. So for this, we need to do a bit of Googling to understand, does this operation support retries? And the special science, the computer sciencey term to Google that is idempotency or idempotent. And luckily, Stripe has a fantastic documentation site that tells us, yes, we actually do support idempotent requests. The way this works is you as the caller, me calling their API, provides some kind of unique key that identifies this transaction separate from other transactions. It's something that you have to provide. Like they don't know, Stripe can't know that 2 transactions coming in at the same time. Even if they're the same amount, they don't know if it's the same transaction. So they said, Stripe says, we're not going to guess. You give us a key, and then we'll make the determination if we've already processed this transaction for this key. So all we have to do on the caller side is to figure out what should that key be. This key needs to map to a unique instance of us charging the customer for some sort of business transaction. And if we go back and look at our code, we can see that, hey, the cart actually represents a unique business transaction. Each cart should only really be charged once. But if the customer, they make this order, they get their order placed, and then like super fast, they go and order the exact same thing, like, oh man, I wanted 2 of those things. Even if they make the same order with the same contents, if they're different carts, that means like they've gone through the process twice, then that doesn't represent a single business transaction, that represents 2 business transactions. Now, not all systems do this, right? If you've used like, I don't know, some chat programs or social media systems, you may have noticed that if you like click the button twice to tweet something or whatever, or post whatever, sometimes it'll say like you just tweeted this or you just posted this. This is we see this as duplicate. So if you try to post the same message twice, it will detect that. So that's another way of dealing with this, which we'll talk about a little bit later. But there are ways for like the receiving system to try to intelligently figure out, is this a duplicate? For us though, Stripe says, I'm not going to try to figure this out. You tell me what your unique key is going to be. And then every time you post a payment where you pass me a key, an idempotency key, we'll go check our database to see if we've received that order, that idempotency key. And if we have, then we won't do anything. We'll just say, yep, I got the payment. You're good to go. All right. Option 3 is undo. Okay, now this one is a little bit trickier. There is no like fancy computer science term we can Google to do this. This is a more business design question. So for us, we have to figure out, what does it mean to logically undo a payment operation? What is the like reversal of that? Remember, this is not in a transaction anymore. So we're not doing a quote rollback. Rollback is very specific, has very specific properties, and is really talking about database operations. For this, we're looking at what does it mean to reverse the transaction, to undo the transaction that we just did before. Well, we're talking about this operation, which is posting a payment. There are a few different terms for this, like it's credit versus debit. But from a kind of user perspective, this would be known as a refund. So refunds are a way for us to reverse the charge of an initial payment. So the first payment has successfully gone through. A refund is just doing the opposite, putting the money back into the account that you had before. And the nice thing about Stripe is that I don't have to like post a negative payment or like remember even how much the charge was. Instead, I tell it, here's the initial payment that failed. And it will go look up the payment by its identifier. It will automatically know like how much to reverse the charge minus a fee, and then give that money back to the customer. Now, in the initial discussion, we said that there was a transaction around all of this. So to make sure that this code actually works, we need to make sure we actually pull in the database transaction as well to show or to capture all of the success and all of the failure operations in this overall like failure mode option that we're exploring here. So down here, if something goes wrong with one of the things that happened above, then if we successfully made a payment, then we'll ask Stripe to refund the payment, and then finally roll back the database transaction in case it committed for whatever reason. So this doesn't account for all failures, right? We can have a failure with refund. So you can imagine like, well, we have to have even like a try catch around there, and we can kind of like have much more complexity around dealing with all these different failures. But first, let's look at the next option on our list, which is coordinate. So this one is again a little bit more difficult. Like, what does it mean to coordinate a payment transaction? We already know that they don't support a formal protocol like two-phase commit or XA transaction, whatever, or WS transaction or WS. There's like a bazillion like formal protocols to do so. But in some of these cases, it might have a more business flow protocol or an application level protocol to deal with this kind of two-phase sort of commit. And so again, we go to the great documentation from Stripe, and this is they actually have this concept of two-step payment flows. And you probably already noticed this in your bank account today. So if you logged in to your bank account and you may get a charge today, you would see at the top of your bank account statement, pending transactions. So these are transactions that for the purposes of what your current balance is, the bank has kind of put their finger on that money and says, this money has been promised to a receiver. And so we're setting this aside. However, the transaction is not going to be completed until the end of the day when those, nightly mainframe cron jobs finally wake up and do the thing for banks. Before those ACH transactions are finally captured and move the money from one account to the other. So Stripe supports this, where they have a two-step payment flow where he says you can authorize a transaction and then sometime in the future capture the transaction, and then the money will be changed hands. And so they support this. So we do something like this. That's inside that ginormous try-catch block. We will, instead of posting the payment immediately, we will post an authorization for the payment. So we'll put our finger on that money. And then after everything succeeds and it went through successfully, we will then capture that payment at the end. Now, this again doesn't deal with all failures. We could have a problem happening at the posting of the payments, like Stripe could go down at that last line of code down there. But at that point, we are in a much better position from a kind of customer service perspective. We could have some admin operation that goes once a day and looks at the uncaptured payments from the previous day and go in Stripe's admin UI, go click, 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 go ahead and capture all those payments. But at least it's actually gone through. All right. So Stripe is one that's dealing with money. And so there's going to be a lot more controls and a lot more options available for us. The next few are going to be quite a bit different in how they, what options are available for failures, as well as how we then deal with those failures. So the next up is going to be SendGrid. Like I said, SendGrid is very different. SendGrid prides themselves on being, very high uptime, but the reason they can be up and so fast is they don't have a lot of the controls that we saw with the Stripe option. Stripe option is doing with money, which we want to protect, and SendGrid is email, which we don't care about nearly as much. So option one, ignore. So this is a good question. Like, well, do we care if the SendGrid service is down? Do we want to prevent any orders from getting processed if I can't successfully send emails? Well, maybe. It could be that we do know that like emails get sent later on in the process. So if they don't get that email right away, then they're going to get another one sometime in the future. So no harm, no foul. So it looks something like this, where we just say, okay, we tried to do the thing didn't work, swallow the exception, log it, of course, but we're not going to stop the ordering processing just because we can't communicate via email. Option two is retry. So in that terrible position as a software developer, where you go Google the thing, SendGrid, item potency, and the only results that come up are Stack Overflow questions with like hundreds of upvotes, no accepted answers or no really answers at all, but just a whole bunch of comments of everyone else having the same problem. And what this effectively means is that this is a problem that cannot be solved in this manner. And so there is no item potency available for SendGrid or like email in general. So if I make a call to SendGrid and I get like a timeout exception, but the email actually got sent, if I call SendGrid again, they will get 2 emails. So I go to the business and say, hey, do you want the customer to get, like, if something goes wrong, that they could potentially get multiple emails? Or if you want something to go wrong, that they don't get an email? Which one do you want? And of course, business is like, well, I want them to get exactly 1 email, which, yes, of course, we would all like that, right? We would all want like to receive each communication only 1 time. But the reality is, because it's not a transactional system and there's no way for us to check to see if something happened, like once the email's out the door, like, well, there's no way for us to like go back and like, did you get that? It's already gone. We can't go check it anymore. The only options for us are to have the customer receive at least 1 email or at most 1. So it's at least once messaging or at most once messaging. There is no exactly once messaging. So we don't do this, we don't retry unless we want duplicate emails. And so we ask the business, like, are you okay with duplicate emails? And it's a question for them, like, do you want duplicates or do you want none in case of failures? Pick one. And it's a business decision on their side, which one they want to do. Option 3 is undo. Okay, of course, there's nothing we can Google here. So we have to think, what does it mean to undo an email? Now, as much as I wish I could like undo emails, it's not something that's actually, possible. We can't unsend an email. Like once we hit that send button, it's out the door and like we can't do anything about it. Now there are ways for us to mitigate this somehow. And so you do see some things like Gmail does this, right? You hit send and for like 5 seconds, there's a little thing at the bottom that says undo send. And the only reason that's possible is because they never actually sent the email in the first place. They're just waiting. They're buffering on the sending side. It says, okay, you said send. I'm going to wait until you're really sure before I actually send the email. But if it's other systems that say like, as soon as you click that button, this thing's getting sent, which is what SendGrid does, then there's really no way for us to like recall that message. So undo, what does it mean? Well, we can't unsend emails. So what is the like logical business version of unsending an email? Sorry, didn't mean to do that. You got the thing. You weren't supposed to get the thing. I'm sorry. So yeah, that actually could be a viable option for us as a business, is just to simply apologize. Option 4, coordinate. Nope, like SendGrid doesn't support this. Like email systems don't support this. They don't support like, put your finger on the email and then tell me again in the future that it's okay to send the email. That's just not a thing. So I don't even know what this would mean here. Finally, RabbitMQ. So this one is similar to email in that it's a asynchronous messaging system. So we're gonna have similar kind of failure modes, but the business perspective for failures is gonna be quite a bit different here because we're dealing with systems versus people. So option one is ignore. Well, what does it mean to ignore an order here or ignore publishing a message? It could be that we just say, okay, maybe instead of publishing the message now, we publish a message sometime in the future because downstream systems are already asynchronous anyway. So maybe we could just make it like even more asynchronous. We say, we'll try to publish the message now, but in case of failure, we'll just like flag the order of needing to have this message published later. And maybe there's some like background job that just looks for these things and goes ahead and publishes the message sometime in the future. Option two is retry. Now, again, a person can, in their head, deduplicate emails. Systems, on the other hand, are different. So in this case where I have a retry, remember if I'm calling RabbitMQ, RabbitMQ itself does not have any deduplication capabilities. If it sees two messages, it will simply publish all those messages out the door again. And so in this case, a retry in RabbitMQ will publish those messages to downstream consumers. Now, some message brokers do have a capability of buffering the messages before it sends them out the door, or having a very short-term memory of messages it's sent to deduplicate them. So Azure Service Bus, for example, does have this capability that for a certain amount of time, it will quote, have a memory of messages. So when it receives it, it'll say, okay, for the last 30 seconds of messages, let me go check to see if I've already sent this message. And if I have, then hey, nothing to do. I've already sent this message. But once that time period passes, duplicate messages will be received by downstream consumers. So it's up to me on the consumer side to deduplicate those messages as they come in. And so I, as a developer on the left side, will go talk to the developers on the right side and ask them like, hey, so is it cool if I send you this message like a lot of times instead of just the one time? And they're like, no, we just want that message exactly once. And then I laugh, but this is messaging. It's, you could either at most once or at least once. There is no exactly once. And they're upset because like, can't you just like fix your systems? Like, why do I have to worry about this? But the reality is like, they can receive messages more than once. So they would have to, on their side, handle messages being received more than one time. Option three is undo. Well, like emails, I can't unsend a message, and I can send an email to a customer apologizing, but what do I send here? Bus.publish, order received. Bus.publish, haha, just kidding. Take back the other one. So compensating message may be weird here. I would still explore it just from like a business logic perspective. Like, is it a cancellation or, I don't know. We'd have to figure out what a compensation message would be, but it would involve business and involve design to understand what that might mean. Option four is coordinate. RabbitMQ doesn't support this. Most brokers I know don't support this. So there's some of them support it kinda with sessions and things like that. But again, they become more expensive, but in our case, we're using RabbitMQ and it doesn't support that. So that was that. So this is kind of the sorry picture that my coworker and I were looking at the end of the first discussion is like, okay, we know that things are bad because it assumes success. We also know that this is a messy picture, right? Like if we start putting in all these funky try catches like everywhere, this is going to be a mess to deal with in the future. So I said, okay, let's take a break. Let's take a breather and then take a step back and say, maybe the problem is we're doing too much at once, that we have a single block of code that is trying to assume that everything succeeds or everything fails. So can I avoid exceptions by breaking some of that process coupling? Instead of having very imperative set of code that, A, B, C, D, E, F all in one synchronous block, can I have something that triggers something else? So it's separated in time, where one thing succeeds at a time, and then it triggers another thing to succeed. So I looked at the first one and said, okay, Does this have to succeed now, or can it succeed sometime in the future? And this is a business question because it matters of like what the operation actually is as part of that initial transaction. Do I need to take the money right away, or can this happen in the future? And in this case, the business said, well, we want to try to take their money, but if it doesn't work, then we can in some cases take their money in the future, but we need to be, let us know. We need to have a human get involved because this can involve like, you know, giving discounts or refunds or who knows what. Um, we need to be involved in the step. So in this case, what we'll do is we'll try to do the payment, but if the payment failed, then we'll just mark the order as having a payment failed, and then an administrator needs to come in and like you do whatever. Like I don't even know. Look at a screen of failed payments and then contact customers, whatever. What about SendGrid? Well, email is already asynchronous, right? We are dealing with asynchronous messaging that might like when as soon as you click the button, it's like the message pops up immediately in my inbox as part of that button click. There is downstream systems and multiple sets of like other transactions that happen in order for that email to actually wind up in my inbox. So SendGrid doesn't have to happen as part of this transaction, but does need to be done as part of something else. So we asked the business, okay, we know we need to send an email. What should be the thing that triggers the email sending? Is it inserting a row into the database? Like, well, no, because we could have problems with payments and the database transaction could fail, and maybe their credit card's bad. So we don't want to tell them that the order was successful if we never actually took their money. The real thing we need to care about is when we take their money, that's when we should send the email. So Stripe allows you to do this. They have webhooks that says, when I have something happen here, I will call an API on your side, and then you can do something else. So we investigated this and said, okay, let's hook a webhook up to Stripe payment successful event, and then it will call our API, and then that API will then go ahead and call SendGrid. So we did look at this, but because of some security concerns, we wound up not going this route, but it is something viable. It is a viable option for us to consider as a whole. So the final one was looking at RabbitMQ. So in this case, we have RabbitMQ that is, again, downstream systems. But the problem is with RabbitMQ is that RabbitMQ is, it can never participate in the transaction of our API. So we know that we want to notify downstream systems when the transaction succeeds, but there's no way for us to really hook those two things up directly. So instead, what we can do is, instead of us sending the messages right away, what we'll do is temporarily put those messages aside, and we'll be putting those messages aside in our database. And this is known as the outbox pattern. In the outbox pattern, we have a table in our database which holds the messages we intend to send temporarily. It just holds them there for a short period of time. And then we have some sort of background process that is then taking those messages and actually shipping them out the door. So it might look something like this, where instead of us like calling bus.publish, instead what we're doing is like dbcontext.messages.insert this event. And then something in the background is like getting messages out and then sending them out the door. So this process still has way too much going on in the context of a single button click. There's just too many things going on in the context of like clicking this single button. So in real e-commerce systems, like real ones that are, I've actually worked on, they use background processing to fulfill orders. They try to keep that initial set of operations as thin as possible, and then as much as possible, ship any kind of more complex operations into something going on behind the scenes. And oftentimes I'll use what's known as the process manager pattern to coordinate those background activities. And so the idea here is that there's a very small initial transaction that is just inserting the order into the database. And then behind the scenes, we're going to be using messaging to coordinate the operations of those downstream systems. And so the final picture will look something like this, where I have an initial operation that is in a single transaction with the API, the API and the database. The process manager will then take that message that is intended to send, say, okay, we got a new order coming in. It will make the initial call to Stripe to say, hey, I need you to go ahead and post the payment. Once that payment is successful, then I can notify all the downstream systems that need to be triggered off of a successful payment, which includes SendGrid and all other downstream systems based on that initial success of the Stripe payment successful. Now, this was like the ideal gold standard that we were shooting for, to say, okay, now we're going to have like messaging everywhere, and each operation will know the successful failure of it. And then if it fails, we'll be able to take, kind of business decisions and business operations to either undo the operation or whatever. So this was like our ideal sort of pictured endpoint. However, in reality, we stopped about, I don't know, 30 minutes ago, and just did the refund and said, we'll put everything in the try catch and mark it as like needing further processing. And then Stripe, if it goes wrong, we'll go ahead and just refund them, because we're like 2 weeks from shipping and there's no way we can get this more complex picture. But all of these different failure modes and different patterns for addressing these different failure modes are things that I would look at when coordinating multiple distributed systems together into these single logical business operations. So if you're interested in more about this topic, there's a fantastic book out there. It's called Enterprise Integration Patterns. All the patterns I talked about today are detailed in that book. And you can go look up there and implement them in your own systems. So thank you all very much. I hope your distributed systems will be more successful than that one there. Thank you all.